Section 5.1, Verifying Trig Identities, Part 2. Example 5, we're going to verify that 1 plus sine of x all over cosine of x is equal to secant of x plus tangent of x. So I'm going to start with the left side here. Something that I notice is in my identity, I have one term on the left side and I have two terms on the right side. So I know I'm going to need to take my left side and rewrite it as two fractions. So we can write that as 1 divided by cosine of x plus sine of x divided by cosine of x. So we're taking both terms in our numerator and we're putting it over the same denominator. It's like we're unsimplifying fractions here. After that, I can replace 1 divided by cosine of x with secant of x. And I can replace sine of x divided by cosine of x with tangent of x, which gives us our identity verified. Example 6, verify that sine of x divided by cosecant of x plus cosine of x divided by secant of x equals 1. So the first thing I notice here is that I have some trig functions that are not sine and cosine. So I am going to replace cosecant and secant with 1 divided by sine of x and 1 divided by cosine of x. Now I have fractions and fractions, which is a little messy. So I am going to use my keep, flip, change method and simplify my fractions and fractions. So I am keeping the numerator the same, so it's sine of x. I'm flipping this, so it's also just sine of x. And I change to multiply. Same thing with my cosines. Next, I know that sine of x times sine of x is sine squared of x, and same thing with cosine times cosine. Finally, I can replace that with 1 because we have the Pythagorean identity that tells us sine squared of x plus cosine squared of x equals 1. Example 7, we're going to verify that 1 minus cosine of x all over sine of x is equal to cosecant of x minus cotangent of x. So I want you to pause your video and try this one on your own. Just a couple of hints in case you're not sure where to start. I see that I'm going from one term to two terms. So just like the last example, I want you to take 1 minus cosine of x over sine of x and rewrite it as two fractions. Simplify what you can, and then you should be at your final answer. So this is really just kind of a two-step problem. So pause your video, try it on your own, restart to see my answer. Okay, so I started by rewriting this as two separate fractions. So I had 1 over sine of x minus cosine of x over sine of x. So I took both my numerators, the 1 and the cosine of x, and I put them over sine of x. Then I simplified 1 over sine of x to be cosecant of x, and cosine of x minus sine, or excuse me, cosine of x divided by sine of x became cotangent. And now we are just going to have, I believe, 5 more examples to go through. So just more practice with trig identities. So this first one I think that you could probably get on your own as well. So I want you to pause the video and try this one on your own and then restart to see my answer. If you're stuck on what to do, start by changing everything to sine and cosine and canceling out what you can. Okay, so I rewrote cotangent as cosine over sine. I rewrote secant as 1 over cosine, and I left sine like it was. I noticed that we can cancel a cosine out of the top and the bottom. Same thing with sine. I have a sine in the denominator and I have a sine in the numerator. So in the end, I'm just left with 1. More practice, example 2. We're going to verify that secant of x minus secant of x times sine squared of x equals cosine of x. So again, if you're feeling pretty confident about this, I want you to pause your video and try it on your own. If you need a little leading, then I'm going to remind you that I see a secant in both of the terms. So I'll probably end up factoring out secant of x and then look at what I have left, and that might be part of an identity that we can simplify. Okay, so the first thing I'm going to do here is I'm going to pull out a factor of secant of x from both terms. Next, I know that I can replace 1 minus sine squared of x with cosine squared of x because of my Pythagorean identity. Next, I'm going to rewrite secant as 1 over cosine. And then, since I'm dividing by a cosine, I can cancel one of my cosine squareds out, and I'm left with just cosine of x. More practice example 3. So for this example, I personally had to look at it for a little bit to think about what to do here. I do see I have a cosine squared and a sine squared, so I can't really use my Pythagorean identity because that uses cosine squared plus sine squared, and this is a minus. So something I noticed is that I do eventually want to get a 1 on the other side of the equation. So I rewrote sine squared of x as sine squared of x minus 2 sine squared of x. So I took that negative 1 sine squared of x and kind of rewrote it as a 1 minus 2. At this point, I see I have cosine squared of x plus sine squared of x, so I can replace that with 1. And I have my identity verified. More practice example 4. So with this example, first of all, I see I'm probably going to want to change my cosecant into terms of sine. And I also have 2 terms on the left condensed into 1 term on the right. So once I change my cosecant into sine, I'm going to look to make common denominators and combine those 2 fractions together and see where that takes me. So if you think you've got this, I want you to pause your video and try it on your own and then restart it to see my answer. All right, so we're going to start by replacing cosecant with 1 over sine. And then I'm going to make common denominators. So I rewrote sine of theta as sine squared theta divided by sine of theta. Now that I have common denominators, I can condense my fractions to be 1 minus sine squared of theta over sine of theta. On the top, I notice that I have a 1 and a sine squared going on, so I can probably use my Pythagorean identity and replace that with cosine squared of theta. Now, I know in my final answer that I'm going to want a cosine and a cotangent, so I'm going to pull one of my cosines off of the fraction, pull it out to the side. So I rewrote cosine squared of theta, it's just cosine times cosine. And then I'm going to replace cosine of theta divided by sine of theta with cotangent of theta. And I have my identity verified. More practice, example 5. In this example, we're going to verify cosecant squared of x divided by cotangent of x equals cosecant of x times secant of x. So we're starting with cosecant squared of x divided by cotangent of x. The first thing we want to do is kind of break these apart. So we're going to rewrite that as cosecant squared of x times 1 over cotangent of x. Now we're going to change everything to terms of sine and cosine. Next, we see that we have a factor of sine on the top and the bottom. So we're going to cancel a sine out of the top and a sine out of the bottom. We still have a factor of sine of x left in the bottom. And then we're going to rewrite these 2 fractions as cosecant and secant. And we have our identity verified.